Tonight on Catalyst, the sweet hope of success, making ethanol a truly viable alternative to fuel.
It's a breakthrough that's sure to surprise the world of science. The world is heading full speed for a fuel crisis. Some oil experts predict we'll hit the bottom of the barrel within 30 years. Ethanol, a form of alcohol, could be the answer, a cleaner, greener fuel made from sugar and starch-rich plants. Unlike oil, it's a renewable fuel source, but current ethanol production makes up less than 1% of our fuel needs.
The problem is that even if we converted the whole of the Australian sugarcane crop into ethanol, by conventional techniques, we still wouldn't have anywhere near enough to drive our cars.
Dr. Paul Atfield and Dr. Philip Bell might have the solution. They've actually managed to unlock more sugar within sugarcane, almost doubling the ethanol yield.
This will open up the possibility to produce vastly more quantities of alcohol.
It's a breakthrough that's sure to surprise the world of science. The sugar source they've unlocked was considered impossible to ferment using non-GM or genetically modified yeast.
Well, one of the first things we expect to see is maybe one of disbelief.
Ethanol is not a new fuel source. In fact, when the Model T Ford was first built in 1908, it ran on both petrol and ethanol. However, the dual fuel system was phased out when oil prices plummeted, making ethanol uncompetitive. But only recently has Australia taken ethanol for a test drive.
We're lagging considerably behind. Brazil went into this in the 1970s during the first oil shock and is arguably the leader in the world in terms of turning sugarcane into alcohol. And they even run cars on 100% alcohol, proving that the technology is viable in cars.
This is how ethanol is currently produced. In the case of sugarcane, it's first crushed. The juice is cleaned of impurities, then taken to the distillery.
These big tanks are called fermenters. So when we've got the cane juice from across the road, we use a yeast culture, we call it inoculation. What the yeast effectively does is it takes the total sugars that are in the cane juice and converts it into ethanol and carbon dioxide.
So this is just like an oversized home brew kit?
Absolutely, yeah.
Oh wow, that's a lot of beer. Once the yeast has used the sugar, the brew is cleaned and purified, and you're left with ethanol. This can then be mixed straight into unleaded petrol to make E10, that's petrol with 10% ethanol. But conventional techniques appear incredibly wasteful. Of the entire plant, less than 30% is used as sugar. And once you've taken that out, you're left with this, a waste product called bagasse. It's either dumped or burnt for energy. But this waste product is actually full of a different kind of sugar. It's called C5 sugar or xylose. Genetic engineers have spent 20 years trying to create a yeast that can ferment xylose on an industrial scale. So far, they've failed. It was considered impossible for natural yeast to ferment xylose at all. But Philip and Paul persevered with old-school selective evolution and came up with a super yeast. So what have we got here, Phil?
Well, what we've got in here is a culture collection, or a sort of a stud farm of yeasts.
Right.
And so what we have is, I'll show you in here, we've got over 2,000 different strains. And what we do is we use these for our genetic raw material.
So it's sort of like an artist's palette with all these different yeasts with different particular characteristics that you can blend together to get exactly the strain you're after.
Yes, exactly. What we need for our process to work is actually need to have a lot of genetic diversity there. And then when we apply our selective pressure to it, we get what we want. That's the evolution of these strains, which is xylose utilising.
And after 3 years of selective breeding, a successful result.
So this shows really what we've been able to achieve. These two flasks both contain water, the C5 sugar xylose. Now what we've done is inoculated into here 2 days ago a standard baker's yeast strain, and you can see that nothing's happened. It basically hasn't grown at all. In this one we inoculated one of our yeast strains that we've evolved, and you can see within 2 days it's grown a massive amount and has in fact used up all the sugar in that flask.
So in this case, your yeast recognises the C5 sugars as a good thing to eat and they thrive on it, whereas normal yeast just doesn't recognise the C5 sugars at all.
Absolutely, and this in fact flies in the face of scientific dogma, because all of the people who have been working on this area in the previous 20 years,
they all said that it's not possible to get yeast to grow on this sugar, but by using the evolutionary approach we've adopted, then obviously it is.
Philip and Paul's revolutionary new yeast has the potential to make ethanol a truly viable alternative fuel to petrol. Because it can unlock xylose sugar, will no longer be limited to sugarcane, corn and wheat. Believe it or not, xylose is found in waste paper and other plant byproducts. It seems like science fiction, but this could actually become the fuel of the future.
there's something like 150 to 200 billion tonnes of plant material made per annum in agricultural and forestry processes, and that would be more than we need to make total replacement of petrol.
This new technology has amazing potential. But Paul and Philip say they're still a couple of years off from converting our old newspapers and garden clippings into fuel.
I think ultimately, as oil depletion becomes worse, we're going to have to replace more and more of the gasoline or petrol with ethanol. And so this is why we need to find alternative sources of making ethanol.